Okay, let's solve. The freezing point in degree Celsius of a solution containing 0.1 gram of K3FeCN6. Okay, we need to find the freezing point of this substance. Basically, it's a coordinate compound. And when you add K3FeCN6 into water, this part outside this square bracket is called as counter ion, and this is your coordination sphere. And when you add this to water, it forms 3 moles of K plus and 1 mole of FeCN6 minus 3 ions, ferrocyanide ions, into the solution. So basically, this substance produces 4 particles. Also, we need to assume in water, this entire molecule dissociate completely. मतलब इसका dissociation is 100%. So for 100% dissociation, alpha value becomes 1. Now, where you are adding this compound? In 100 gram of water. So water is your solvent. Also, they have given us molar depression constant, that is 1.86 Kelvin kilogram per mole, and the molar mass of the compound. Plus, the mass of solute is also given to us. So this is a mass of solute. This is 100 gram is nothing but the mass of solvent. And we need to find its freezing point. So suppose in a beaker, I'm taking 100 gram H2O. In this, I'm adding 0.1 gram of K3FeCN6. So this becomes a solution. And we need to find out in degrees Celsius the freezing point of this solution. Okay. But when you add this compound to water, we assume it undergoes complete dissociation. So when it undergoes complete dissociation, we get 3 moles of potassium ion and 1 mole of ferric cyanide ions. Okay, so total particles are 4. So when you apply the formula for dissociation in solution, you get alpha is equal to I minus 1 upon n minus 1. Where alpha is 1 because of complete dissociation, I is your went off factor, and n is the number of particles after dissociation. But because of complete dissociation, alpha value becomes 1. Therefore, I minus 1 is equal to n minus 1. And when you cancel this common terms from both sides, when the 1 is common, you get I is equal to what? N. And here, the number of particle after dissociation is what? N. That is 4. So ultimately, the I value becomes what? 4. So use this I value when the molecules are undergoing dissociation or association. So this formula is for what? Dissociation. So I use this formula. I got the value of I, and always remember, if it is completely dissociated, then alpha value is 1 only. So I and n become same for complete dissociation. So whenever it is complete dissociation, just calculate the number of particles produced after dissociation. That becomes the I value. Now let's proceed. Now we will use a formula that delta TF is equal to I into KF into M, where delta TF is nothing but the depression in freezing point, that is formulated as T naught F minus TF, where T naught F is the freezing point of solvent, that is 0 degrees Celsius since your solvent is water, and TF is freezing point of solution, which we need to find out. I value, just now we found out I value is 4 because of complete dissociation. KF is 1.86. Now regarding molality, so molality is nothing but mass of solute upon molar mass of solute into mass of solvent in kilogram. Okay. So when you use this formula, the mass of solute is 0.1, molar mass of solute is 329, and the mass of solvent is 100 gram. So if you convert them into kg, it becomes what? 0.1 only. So this get cancelled out. Now for the calculation, 4 into 186. I'm taking this decimal out for 2 digits. So I'll write down here 10 raised to minus 2 divided by 329. Now for the fast calculation, Assume this 329 as 330. You want a close answer. Okay, so you get the answer at a faster rate. So even it is 330. Okay, do some kind of adjustment. And if I consider this as suppose 186 hai. So if I consider this as 187, then clearly 11 may in 11 table 11 threes are 33. Okay, so you get this as 11 threes are 33. Now this becomes what? 0. Now 187, 11 ones are 11. How much is remaining here? 7 is remaining. So 11 sevens are 77. Now 4 into 17. So when you take 4 into 17, it becomes what? 68 into 10 raised to minus 2 divided by what? 30. Now if you remove this 0 here, it becomes what? 6.8 into 10 raised to minus 2 divided by 3. So ultimately, your answer is when you divide it 6.8, you divide this by 3. So you get around 2.26 into 10 raised to minus 2. Now this answer and this answer, if you see properly, is for delta TF. Now, can we write down here that delta TF is equal to 2.26 into 10 raised to what? Minus 2. You remove this 6, so you will add it as 2.3 into 10 raised to minus 2. But what is delta TF? T naught F minus TF. Now, what is T naught F? 0 degrees Celsius. So 0 degrees Celsius minus TF for the solution is equal to 2.3 10 raised to minus 2. So finally, the freezing point of solution becomes minus 2.3 into 10 raised to what? Minus 2. That is option A is the correct answer. I hope you all understood. Thank you.